computer.
Yes. Okay, I'll start the presentation. Asking, you can start.
Yeah. Hi guys, this is the presentation by Group 1 for Fall 2020 semester. So we'll be presenting on topic MapReduce types, formats and features. Can you go to the first slide? Okay, so big data is basically a collection of large data sets that cannot be processed using traditional computing techniques. For example, Facebook and YouTube, they require large amount of data to be collected and managed on a daily basis. So this kind of data is referred to as big data. Basically, big data involves one of the following aspects, that is velocity, that is the amount of data that comes in, the variety of data, the volume of data, and the complexity. So in traditional enterprise system, what we normally have is a centralized server that is used to store and process the data. You can see the illustration that is presented here. It depicts a schematic view of the traditional enterprise system. Traditional model is certainly not suitable to process huge volumes of scalable data and cannot be accommodated by standard database servers. So in order to overcome this issue, Google used an algorithm called MapReduce. In MapReduce, what happens is that a task is divided into small parts and each of the tasks is assigned to a different computer. Later, the results are all collected at one place and integrated to form the result database. The resulting data set. So we can go to the next slide, please. So the MapReduce algorithm basically occurs in phases. So the main two tasks are mapper and reducer, which will be discussed in the further presentation. So the stages that we have here are input phase. In this, we have record reader that translates each record of the input to the tuples, which are in key value format. And map will be a user-defined function which will take the key value pairs and generate more key value pairs. And then the mapper will generate some intermediate keys which are combined by the combiner. Then the combiner will send it to the shuffle and sort such that all the keys will be taken at once, and those keys will be sent to the reducer, which will perform an aggregation and do the final execution. And then we finally have the output phase where the records are written to the output file. I think the next person can continue.
Some key features of MapReduce are counters. They are very useful for getting statistics of a job and also help us determine the quality of the job. Apart from that, they can help us in diagnosing any problems in MapReduce jobs by providing logs. The kinds of counters are built-in and user-defined. Built-in counters can tell us how many bytes have been read or written. User-defined, we can make to fulfill the needs, fulfill our needs. Next is sorting. MapReduce can sort data partially, completely, and have a secondary sort. Next is joins. MapReduce can perform different kinds of joins between data sets. The mapper tags each record with its source and uses join key as the output. Can we move on to the next slide? Using the job configuration. So MapReduce uses key value pairs for job configuration. It makes the job faster. Next is distributed cache. So MapReduce doesn't have a single point of server. It uses distributed server for faster computing. Site data distribution. It is the extra read-only data that is needed by the job to process the main data set, but sometimes it's very difficult to find it. And lastly, MapReduce has multiple library classes, which basically makes it easier for the user to not have redundant code all the time. Yeah, next person can take it from here.
Okay. So there are main two functions of MapReduce, which is mapper and reducer. So MapReduce filters and distributes out work to various nodes within the cluster or map, and this functionality of MapReduce is called as mapper. The input to mapper function is a block of data. It reads the block of data and processes it to give us an intermediate output, which is key value pair. The next function of MapReduce is the reducer. Uh, MapReduce collects, organizes, and reduces the results from various nodes within the cluster, and this functionality is all referred as reducer. The output of mapper function is an input to a reducer function. Is an input to the reducer function. The reducer receives the key value pairs from multiple mapper functions and aggregates these intermediate data tuples into a set of small tuples or key value pairs, which are the final output for our MapReduce. The next slides will be taken by Ayman.
So before we discuss the input format, it's important to understand the underlying structure in Hadoop to handle the input file. As we can see, the input format is the base that use files as their data source. It provides two main things: a place to define which files are included as an input to a job, and an implementation for generating splits for the input files. The job of dividing splits into records is performed by subclasses. It's important to notice that the split is a chunk of an input that is processed by a single map, where each map processes a single split. And each split is divided into a records. And the map process each record a key value pair in turns. It's important that splits and records are, it's important to understand that splits and records are logical, not as physical as HDFS blocks. There is nothing that requires them to be tied to a file physically. In general, an input split has a length in bytes and a set of storage locations, which are just like the host name strings. Notice that the split doesn't contain the input data. It's just like reference to the data. The reason for that is the storage locations are used by the MapReduce system to place a map task as close as possible to the split data. And the size is used to order the splits so that the largest get processed first in attempts to minimize the job runtime. As a Hadoop developer, you don't need to deal with the input splits directly, as they are created by an input format in general. Next slide, please. Next slide. So there are like many types of input formats. In general, we can categorize the input format as like four main categories here, which is the text input, the binary input, and the database input, and multiple input. Where in text input is the default input format, where the length of the split depends on the size of like the size in bytes. And the key value text input format is where each line represents as a key value separated by delimiter, usually tab delimiter. And inline input format is to ensure that every mapper receives a fixed number of lines, and XML is usually a good option if dealing with the whole file, because most XML parsers process on a whole file. So usually splitting XML files usually is overwhelming to the system. So the binary input, in general, it's just like a sequential binary. We have like three main types, where the sequential binary to textual input, where every binary is converted to a string. And when we say converting, is we are converting the key and the value. And the sequential binary inputs, where we are dealing with, or let's say it retrieves the sequence of file keys and values as opaque binary object. Finally, the fixed length, where like the reading fixed width binary records from a file. Database input usually used to read a relational database. And lastly, multiple input is where you can have like multiple input formats, and you can use it as a process. Next to the guy who's next.
So I'll be explaining output formats. Output formats is very similar to the input formats as explained by Ayman. To be simply put, output format checks the output specification of the job. Now, before getting into that, we should know what a record writer is. A record writer writes the output key value pairs from the reducer phase to the output files. Now, the way these output key value pairs are written into the output files is determined by the output format. Now, the output files are written either to the HDFC, the Hadoop distributed file system, or even to the local disk. The next slide, please. Next, we have the types of output formats in MapReduce. So first, I'll be talking about text output format. This is the default output format, which writes the key value pairs on individual lines of text files, and the keys and values can be of any data type. Next, we have sequence file output format. It writes sequence files for its output, and it is the intermediate format which is used between different MapReduce jobs. There is also sequence file as binary output format, and it is almost similar to the other one, except for the keys and values are written in binary format. Then we have map file output format. It writes output as map files. The key in the map file must be added in order to ensure that the reducer emits the keys in sorted order. Next, we have multiple outputs. It allows writing data to files whose names are derived from the output keys and values. Next, we have lazy output format. This is basically a wrapper output format, which ensures that the output file will be created only when the record is emitted for a given partition. That is, if the output file is not empty. Next, we have DB output format. This writes to the relational databases. This writes the files to the relational databases and HBase, and sends the reduced output to an SQL table. So the return record writer writes only the keys to the database with a batch of SQL query. Next, sorting counters will be explained by Sridhar.
Thank you, Aditi. So I'll be talking about counters. Counters in MapReduce are used to gather statistical insights from about a job, and also they can be used to diagnose problems. There are actually two kinds of counters. One is built-in counters, and the other is user-defined counters. So under built-in counters, we have task counters. These task counters usually gather information about tasks, and the results that are generated from this is aggregated for all the tasks. And we have job counters. This is actually maintained by the application master, and this is used to measure the job level statistics, such as total number of map and reduce tasks that are performed. Then we have dynamic counters under user-defined counters. So dynamic counters are actually created by the application developer, and they are usually created using Java enumerators. Then we have retrieving counters. So this actually provides job level statistics when the job is executing, unlike other counters that actually aggregate data after the job ends. Can we go to the next slide, please? We have sorting. So Sorting actually falls in between the map and reduce phase, where sorting at the heart of map reduce is actually the sorting phase. In the sorting phase, we have keys that are sorted, and these keys are actually given to the reducer, which creates a new task for all the keys that are there. And there are different kinds of sortings. One is a partial sort. Partial sort is when is the default sort that happens in MapReduce framework, and in this you have the outputs of all the tasks, but they are not combined to form a global output file. Then we have the total sort, which actually tells us that we have the global output file that is generated from all the partial sorts that we have. And then we have the secondary sort. So secondary sort is used when we have to actually sort the reducer values. And joins will be explained by Bharadwaj.
Thanks, Sriram. So coming to join in SQL, so joins and MapReduce are similar to joins in SQL. So join operation is basically used to combine two or more database tables based on foreign keys. So whenever two large data sets are there, and then when you want to derive a common entity between the two large data sets, then a join can be performed on both the tables. So basically, in general, the companies maintain separate tables for customer and transaction records in the database. So in order to fetch the common entities between customer table and transaction records, we perform a join in MapReduce. So typically, speaking about MapReduce joins, there are two types of MapReduce joins. So one is performed with the mapper, one is performed with the reducer. So coming to MapReduce joins, so it is either this once it is distributed, so either the mapper performs the join or the reducer performs the join on the and then gives the output record. Rohan, can we go to the next slide, please? So coming to the map side join. So whenever the join is performed by the mapper alone, so then it is called a map side join. And this type of join, the join is basically performed before the data is actually consumed, and basically a shuffle sort operation is performed, and then we arrive at the output. And then coming to the reduce side join, this join is basically performed by the reducer, and hence the name reduce side join. So in this, one major advantage for reduce side join is we basically no need to kind of join to this. There is no necessity in this join to have a data set in a structurized or an organized format. So it is also called as a partitioned join, or and then map set join is called a repartition join. Can we move to the next slide, please? Yeah. So this one is an overall process flow of joins in MapReduce. So as I mentioned previously, so we have two tables by customer table and department table. So whenever a mapper performs join, it is called a map join. And then after let's say the table employee and department are mapped, and then a shuffle sort operation is performed, and we derive it out. And then after this one, the reducer reduces the tasks that are there, and then it kind of forms a dictionary, so which consists of a key and value pair, and then we arrive at the final output, and that is what is the reducer does. Can we move to the next slide, please? So yeah, map set joins are also known as parallel scans. So since data is distributed or shuffled according to each and every kind of tables in mapper, so this is the reason we call it as a parallel scan. So if there's if data sets are if sorted by join key, then join can be accomplished by a scan over all the data sets. And then in MapReduce, there's also like two exclusive joins in reduce side joins. One is the one-to-one join and one-to-many joins. So can we move to the next slide, please? Yeah. So as I've mentioned, reduce side join is also called as the repartition join or repartition merge sort join. Since I mean, data is not necessarily need to be partitioned, so hence the name repartition join. So this type of join, as mentioned, would be performed at the reducer end. So it actually, so if you go to the workflow diagram of MapReduce, so shuffle sort operation happens, and then reducer side join takes place. So reducer joins basically uses few key terminologies like data source, tag, and group key. So data source is referring to the data source file, probably taken from the relational database. Tag would be very easy to tag each and every record, or to distinguish each and every record. Tag is used in the MapReduce phase. And group key is referring to which column it should be grouped, or to the join key between two data sources. It is basically a common entity which is present in both the columns on which join is performed. So hence the name group key. So on that entity only, the join is performed. So this is an implementation phase for both map side join and reduce side join. So once we get the input data, map function maps the common entities between the customer table and the transaction table in the HDFS file system. Then sort and shuffle operation happens before the reducer phase, and then reduce side function performs reduce side joins, and then we arrive at an output. Next slide, please. So, key differences between map side join and reduce side join are: map side join, as explained, it happens on the map side, and reduce side join happens in the reduce side. Map side join always happens in the distributed file system, I mean, in the HDFS memory allocation, whereas reduce side join happens off the memory. And there's no track to keep on the memory in reduce side join, whereas map side join requires HDFS file system. And map side joins are effectively used when data set is big, or on large data sets, map side joins are performed. And whereas reduce side joins effectively work on huge bulk data sets. And then map side joins are expensive, and reduce side joins are cheap. So hence the reason when we work on large data sets, reduce side joins are used when compared to map side joins, because map side joins are only used for small data sets, and then reduce side joins are used on bulk data sets. Next slide, please. And so far as the conclusion is concerned, MapReduce is is the processing layer of a HDFS file system, and it is used for processing large volumes of data in parallel and in sequence by dividing the work into small chunks of independent tasks. And hence the name, it is called HDFS, distributed file system. Instead of processing all the data at once, we distribute the data into multiple chunks, and then we process each and every data individually. Hence the name HDFS, Hadoop Distributed File System. Thank you.